Alright, so in this video we talk about Statistics 1, and the first chapter of Statistics 1 uh, that I teach is basically called Summarizing Data. Now, if you're using your Cambridge endorsed book, the chapter of Summarizing Data isn't quite named just like this. In fact, Summarizing Data consists of the few sections that deal with, for example, um, measures of central tendency, and measures of spread. All right. So if you're using a book and you don't quite find the topic of summarizing data, I'm sure you will come across these two topics on the content page of your book. So it's it, it's this chapter deals with basically these two sections, central tendency and the spread of the data. All right. And I'm going to go over all of these things, what each term means, and how do we go about calculating the values that are important uh, when it comes to associated with these terms. All right. So what exactly is this about? Let's say you have a data set. Let's say, right. So what exactly uh, is summarizing data all about? So like I was saying, let's say you have a data set. Let's say you have the marks of the percentage marks of 10 students who have uh, taken a test or an exam. All right. So let's say these are the scores: 75, um, 80, 99, someone scored a 77, someone scored 100, 82, 83, 71, someone failed miserably, 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's say someone else also scored 100, all right? So these are the scores of the students who took the test, all right? Now, usually data set or data values are usually not that small, meaning we don't usually deal with such a small number of data. All right. We usually deal with large, vast amounts of data. So when it comes to those large amounts of data, all right, what we want to know are a few pieces of information about the data set. For example, we want to sometimes, instead of looking at all the values, we want to get a summary of the values. All right. We want to get an overall picture of the values. All right. So let's say teachers often calculate the class average of a particular subject, the average score of all the students scored in a particular subject. Why is that important? Because it gives you an idea of how well the students generally did in the test. All right. So in this case, the average, which from mathematics D, you should be aware of, is called the mean of the data, gives us an overall idea, all right, of um, how well the students did in the exam or how bad they did in the exam, right? So the mean is an example or a quantity that gives us an idea of the central tendency, meaning it's almost like it gives us a central value of the entire data. It gives us a summary, an overall picture of the data. All right. So let's say we go ahead and calculate the average or mean, and I'll show you the formula in a bit. And let's say we got a particular value. Let's say we got something around 79.5. So when I look at this and I look at, let's say, a student who scored something around 75, all right, um, I would basically say, all right, the person did not really do that bad compared to the class, all right. So these are some, you know, deductions that I can make using the mean value or central tendency value. So, so that is why mean is important, right? It gives us a picture of the overall data set. Um, So mean is one measure or one quantity that deals with central tendency. Now, central tendency can be thought of an overall picture of the data. Another quantity or measure of central tendency is called median. Median, by definition, now while mean is the numerical average of your data set, median is also a value that deals with central tendency or gives us a picture of the overall data set. But median, on the other hand, is literally the number or value in the middle. That's what median means, right? So this is something you should have known, you should know from Math D. Now, we'll get into the details of when to use which value, right? Whether for this data set it is more appropriate to use a mean or the median is something we'll discuss in a bit. But the last measure of central tendency, or an, gives us an overall picture of the data, is the mode. The mode is the number or the value in your data set that occurs most frequently. All right. So, so this is the most frequent value. Now, sometimes the mode does help us, right? So mode is another value that deals with central tendency. Now, before I get into the theory, let us first figure out what are the ways we can calculate the mean, median, and mode of different kinds of data set. All right. So let's start with um, the mean. All right. So since we know mean, all right, is the average, the formula is pretty simple. You add all the values in your data set and you divide it by the number of values. This right here is xi. So for example, your data set looks like this: x number 1, x number 2, x number 3, all the way till x number n. So let's say you have these many values in your data set. All right. So you add x number 1, you add x number 2 and x number 3, and that put it all in here in the summation part. This is summation. This means addition of all the values. And this gives you what we call the mean of x. This is x bar. X bar means the mean of the data set with of x values. If I had a data set that I named y, for example, y1, y2, y3, and a bunch of values that extended up to yn, the mean of these y values would have the symbol y bar. Okay, so the most basic formula for mean is this: you add all the numbers divided by the number of numbers. Sometimes it's not really that simple. Sometimes data may not be given to us in this way. Data may sometimes be given to us in the form of a frequency table, x and frequency. And again, you've come across frequency table before. Let's say this frequency table gives us an idea of the number of pets, the number of pet animals in a particular city per family: 0, 1, 2, 3. Let's say 11 families in a city have no pets. Let's say 20 families in a city has one pet each. Let's say 9 families in the city have 2 pets each. And finally, only 3 families in the city have 3 pets each. So there are a total of 20, 40, 43 families in the city. Now, if I asked you to find the mean of x, I'm basically asking you what is the average number of pet animals per family in the city. So in this case, the formula is this: x bar is equals to the summation of xi into fi. divided by the summation of the frequencies. What this means is, in this example, if you name this one x1, this one's gonna be f1. If this is x2, this one's gonna be f2, and so on. This says, look, take the x1, multiply it with f1, plus take the x2, multiply it with f2, plus take the x3, multiply it with f3, and add them up and get this value divided by the total number of frequency. So the total frequency, in this case, it's 43. All right. So this gives you the mean value when you're using a table. If you want to understand why the formula looks like this, well, think about it. If you were to, if this table was converted into a list, it would have looked like this: 11 zeros side by side, showing that 11 families have 0 pets, right? And then 20 ones listed side by side, right? And then the 9 twos, and then the 3 threes. You would have to add them all up and then divide it by 43. Instead of adding 11 zeros, what I did is took a zero, multiplied with 11. Instead of adding the 20 ones, I added the ones, I multiplied the one with 20. Instead of adding the 3 threes, what I did is took a 3 and multiplied by 3, right? So this made the calculation very easy. So that is how you calculate the mean when it comes to table form or tabulated data. All right. Next up, we look into another kind of table, but in this case, the table does not have discrete x values, meaning these whole numbers. Rather, the table has range of values. All right. What do we do there? So what happens when the table has a range of values given? So, for example, oops, let's say, right, let's say these are your x values and these are the frequency, except the same thing, right? Let's say the frequencies are 9 and then 11 and then 20 and then there's a 3 and then there's a 5 and then there's a 2, let's say. But the x values are given in the form of ranges: 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 6. All right. So let's say, again, these are, let's say, the number of kids in a family. All right. Or the number of members in living in a house in a city. All right. So let's say, all right. So that is a terrible example, but I really can't think of an example. Let's think of something. Let's say these are the mm, ages of the children in the houses in a city. All right. So let's say 9 houses or 9 families have uh, or there are 9 kids in the city who are aged between 0 to 1 years. There are 11 children in the city who are aged between 1 and 2 years. Could be 1.3 years, could be 1.5 years, meaning 1 year, 6 months, and so on. All right. And if I had asked you to find the um, mean of this data set, again, the formula would look somewhat like the previous formula. So this is formula number 3. The formula would look something like this: summation of xi fi divided by summation of fi, right? The summation of the frequencies in the denominator, and then the summation of the products of the x values and the frequencies on the numerator. But these are ranges right over here, 0 to 1, 1 to 2, 2 to 3, right? So what x value do you take? Do you multiply the 0 with 9 or 1 with 9? Do you multiply the 11 with 1 or 2 with or 11 with 2, right? In that case, we need to form another table which has the mid values of x. So 0 and the 1 has a mid value of 0.5. This has 1.5. 2 and 3 has a mid value of 2.5. 3 and 4 has a mid value of 3.4, 3.5, and so on. So in this case, it's not going to be xifi, rather it's going to be xmi into fi, meaning take the mid value multiplied with the frequency. Take the mid value multiplied with that frequency and then add them all up for the numerator divided by the denominators. In this case, the denominator is going to be the summation of the frequencies. 20, 20, 40, 40, we have a 50, we have 50 kids in the city, for example. So that number is going to go down here. All right. So that is these are the three different formulas for calculating the mean or the average of your data set. Another important value that is that gives us a measure of central tendency is the median. Now we'll discuss where to use a median over the mean in a bit, but um, let's discuss how to calculate the median first. For very simple cases, let's say you have 5 pieces of data. Let's say again, these are the percentage scores. Someone scored an 80, someone scored a 70, someone scored a 72, someone scored 100, someone scored a 50%. The first thing you want to do before calculating the median is arrange them. Arrange them in ascending orders, smallest to biggest. 50, 70, 72, 80, 100. Now, the idea is to find the number in the middle. In this case, it's quite easy to find that the number in the middle, right? This and this cross out, this and this cross out. The number in the middle is 72. We say 72 is the median value. 72% is the median value. It is the central value. Okay? So that was quite simple. But what happens when we have an even number of values? Okay. Well, when we have an even number of values, what we do is, again, 80, 70, 72, let's say we put a number, a disastrous number, let's say 15, 100, and then 50. We have 6 values here instead of 5. What we do first is, again, organize them in ascending order. And then spot the number in the middle. However, there is no number in the middle. You have 3 numbers here, 3 numbers here. The middle number is supposed to be somewhere here. The middle number, thus, is something you have to calculate, something you can't spot clearly. It's an imaginary number right between 70 and 72. So 70 and 72 will have an average of 71. So when it comes to an even number of data values, you have to do an averaging for the middle value. For the odd number of values, meaning when the number of numbers are odd, in this case 5, you don't have to do any averaging because the middle numbers comes right out of the data set. So in this case, the median is 71. So these were quite simple because we were dealing with only a few number of values. For example, 5 and 6 values over here. But what happens when you're dealing with, let's say, 52 numbers? What happens when we're dealing with, let's say, 57 values? Well, we can come up with formulas. And these are 2 important formulas you have to remember. The first one, when you're dealing with an odd number of numbers, the median is located at the n plus 1 divided by 2th position. What does this mean? It means if you have 5 values where n is 5, the median is going to be at the 5 plus 1 by 2, which is 6 by 2, which is the third. So let me just RD is possible, right? So this bracket number becomes a 3. So the median is located at the third position after you have done the ascending order. So in this case, 1, 2, 3, third position. Now, 3 is not our median. This is a common mistake. People think, students often mistakenly say, look, we have 5 values, so 5 plus 1 is a 6, by 2, that's a 3. 3 is the median. No, 3 is the position of the median from first to last. So for example, if you had 57 values, 57 students submitting their marks, the median is going to be at the 57 plus 1 by 2, which is 58 by 2, which is the 29th position. So when you've arranged it in ascending order, the 29th number is your median. All right. So this is something you have to remember. Shortcut, a trick. However, what about this? Whenever we're dealing with an even number of values, the median is the average or the mean of the n by 2 th number and the next number. So if you're dealing with 6 values, what is n by 2? 3. What is the next? 4. The median isn't the average, is not the average of 3 and 4. The median is not 3.5. Rather, the median is the average of the third number and the fourth number after you have organized it in ascending order. So in this case, the third number is 70, the fourth number is 72. So in this case, the average is 71. So why is this important? Let's say someone gives you a list, a big list of numbers, let's say 50 numbers organized in ascending order. You need to jump to the median. What do? You say, look, we have 50 numbers, n is 50, so I have to follow this rule. The rule says the median is the average of the 50 by 2, 25th and the next 26th number. I'll jump to the 25th number, I'll jump to the 26th number, and I'll do their average and then figure out the median. So I hope that's clear. The last measure of central tendency, something we don't really have to calculate, is called the mode. Now, mode is basically the number that occurs most frequently. So we just look at the number that occurs most frequently or has the highest frequency. That x value is the mode. X with highest frequency. All right. So that's that. We are done with central tendencies. Now a bit of theory. Sometimes when we look at our data, we have 3 measures of central tendency: mean, median, mode. Not all data for all data sets, mean isn't the best value to represent the data or summarize the data. Not for all values, all data sets, its median isn't the right measure of central tendency either. Every value will have a different appropriate measure of central tendency. So how do we know which is the best measure of the central tendency of a particular data set? Let's say you have a data set and someone asks you, summarize this data for me. So you have a dilemma. You need to choose one of these. একটা choose করে তোমার বলতে হবে যে, all right, the summary is the mean and mean has the value of this. Well, normally mean is the best measure of central tendency. For almost all kinds of data, we calculate the mean and present that as the summary of the data. the average, except 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 when there are outliers. Outliers is a statistical term. We don't have to go into the details, but for now, just remember outliers are abnormally large, or abnormally small data values. So, what does this mean? Let's say I have 5 students in my class. Someone scored a 90, someone scored a 91, someone scored an 89, someone scored a 93, and someone scored again another 90. So this is a genuinely, good scoring class, right? Of 5 students. If you calculate the mean of this data set, or mean of my 5 students, you'll see that the mean comes out somewhere around 90. But let's say a new student comes in, and the new student flunks terribly, scores a 20. If you go ahead and calculate the mean of this new data set, let's see what it comes out to be. 93 plus 89 plus 20 divided by 6. Whoops. 473 divided by 6. Guess what? The new data set, because of the new student scoring so less, the class average falls to 78.8%, just because of that one bad score, just because of that abnormally low score or outlier. Does that mean the rest of the class is bad? Does that mean the rest of the class is a low scoring class? Is this really the right measure to summarize this entire data? Definitely not, because this is an outlier, this is an abnormal value. Just because of one or two abnormal values, your entire mean may be disrupted. In such cases, we do not choose outlier. We do not choose mean as our central tendency. মানে mean calculate করে বলি না, this is the right measure. তখন we turn to the median and find the central value. Mode is hardly ever used. Mode is used when the data has one value that is very much repeated. So for example, we have outliers, but there are many students who scored exactly 90. তখন we say, look, the mode is 90, and 90 is a good measure of the central tendency. It gives us an appropriate picture of my data set. All right. So summarizing data. So we are only part way through the summarizing data section. We talked about mean, median, mode in greater detail than we had talked about back in O levels. But there are other things remaining. For example, how widely the data is spread. Next time we talk about interquartile ranges. We talk about quartiles. We talk about new things called standard deviation and variance. These also fall in summarizing data section, but these deal with measures of spread, how widely your data is spread. That the spread is also important summarizing information for data. It also helps us to get an overall picture of the data. Lastly, we also will talk about a few diagrams, plots, the stem and leaf diagram, and box and whisker plot or box and whisker diagram. All right, these are coming up in the future videos. Thank you.